We're diving into a research paper today. It's called Unifying Generative and Dense Retrieval for Sequential Recommendation.
Okay.
And basically, it's looking at how these online platforms, figure out what you might want to buy or watch or play next.
Uh-huh.
And it's comparing two main approaches. So we've got dense retrieval, which is kind of like the tried and true method, and generative retrieval, the new kid on the block.
Right.
So you can think of it kind of like, you've got your well-worn map and you've got this like cutting-edge GPS.
Okay.
And each has its own strengths and weaknesses.
Yeah.
So dense retrieval, it's reliable, maybe a little bit bulky, but it gets you where you need to go.
Yeah.
Whereas generative retrieval, very sleek, efficient, but sometimes it leads you astray, especially in those brand new places where it hasn't really mapped things out yet.
Right.
So let's start by explaining these two approaches a little bit more. So dense retrieval, it relies on these complex calculations to find similarities between items based on, what you've done in the past, what you've bought or watched, that kind of thing.
Mm-hmm.
It's almost like connecting the dots on this giant chart to figure out, like, your taste coordinates.
Right, like finding similar items in a vast library based on your past preferences.
Yeah. And then you've got generative retrieval, which is more about trying to predict, like, what you'll want next.
Mm-hmm.
It's almost like a mind reader trying to guess your next move.
Yeah.
And it uses these things called semantic IDs.
Right.
And these are like shorthand codes for all the different items. And that makes it super efficient.
Right. It's a compressing information, making the process faster.
Yeah, so the researchers, they wanted to see how these two approaches stacked up against each other.
Okay.
So they did this side-by-side comparison, made sure that both of the models, had the same information to work with. And they tested them on datasets from Amazon. They looked at beauty, sports, and toys. And they also used data from the gaming platform Steam.
Interesting.
What they found, though, was that dense retrieval, it actually consistently performed better.
Really?
Yeah, especially with, new items, those cold start items, the ones that didn't have a lot of user data yet.
I see. That makes sense, especially with the cold start problem.
Yeah, and that's kind of one of the key things that they dug into, like, why was there that difference? And one of the big factors seems to be how each model deals with those cold start items, right?
Yeah.
Because dense retrieval, it can leverage those text descriptions even for those brand new items.
Right.
But generative retrieval, it struggles because it's relying so much on those past patterns.
Makes sense.
But here's where things get really interesting.
Okay.
The researchers, they developed this hybrid model called LIGER.
LIGER.
Yeah, Liger.
Okay.
And it combines the best of both worlds. So think of it like having your map and your GPS working together.
Oh, I see.
So LIGER uses generative retrieval to quickly narrow down the possibilities, and then dense retrieval to make that final, more informed recommendation.
Interesting, like a two-step process.
Yeah, exactly. So let's kind of unpack, how generative retrieval actually works under the hood.
Okay.
So it usually involves two stages of training.
Right.
The first stage, it focuses on creating those semantic IDs.
Okay.
So they feed in all those item descriptions into a language model. And it generates these things called text embeddings, which are like these dense representations of the text.
Right.
Then they have a special model called, it's called an RQVAE.
RQVAE.
Yeah, it's a mouthful.
Yeah.
And it converts those text embeddings into the semantic IDs.
So it takes those dense representations and turns them into codes.
Yeah, and the RQVAE, it uses these code books.
Code books.
Yeah, it's kind of like dictionaries. And they map specific text features to codes.
Oh, I see.
And then they combine those codes to create a unique semantic ID for each item.
That's clever.
Yeah, and then the second stage of the training, it focuses on predicting the next item in a sequence using those semantic IDs.
Got it.
So the model is trained on, user interaction histories.
Right.
But instead of using the actual item IDs, it uses those corresponding semantic IDs.
So it's learning patterns based on the codes, not the actual items.
Yeah, exactly. So the model's learning to predict the next semantic ID in a sequence based on the ones that came before it. And this is where a transformer model comes in.
Okay, transformer model.
Yeah, and that's a really powerful neural network that's designed for understanding sequential data.
Right.
So it takes in that sequence of semantic IDs and tries to predict the next one.
Kind of like predicting the next word in a sentence, but with item codes?
Exactly. Yeah, and then during inference, so when the system's actually making recommendations,
Right.
it uses this technique called beam search.
Beam search.
Yeah, and that explores all these different possible sequences of those semantic IDs to find the most likely one.
Oh, okay, so it's trying different combinations to see what fits best.
Yeah, think of it like navigating a maze, trying different paths to find the best route.
Makes sense.
And then once it finds, a likely sequence of those semantic IDs,
Mm,
it translates them back into the actual item recommendations.
right. Back to the real world items.
Exactly. So that's kind of generative retrieval in a nutshell.
Okay, that's helpful.
Now let's shift gears a little bit and look at dense retrieval.
Sure.
So it also involves learning these item representations,
Mm-hmm.
but it takes a different approach.
Okay.
So they still use text embeddings.
Right, those dense representations of item descriptions.
Yeah, exactly. But they also use these things called learnable item embeddings.
Learnable item embeddings, what are those?
Yeah, so think of those as like coordinates that capture the essence of each item.
Interesting.
And these vectors, they're learned during training, and they're constantly refined as the model sees more and more data.
Okay, so they're adapting over time.
Yeah, and in this research, they use what they call a transductive setting.
Transductive setting.
Yeah, and basically, it means that they're leveraging the text descriptions of all the items up front during training.
Oh, I see.
And this helps the model learn these richer item representations, especially for those cold start items.
Makes sense. So it has more information to work with from the beginning.
Yeah, and they combine these learnable item embeddings with the text embeddings and these positional embeddings that basically indicate the order of the items in a sequence.
Okay, so they're taking into account the order too.
Yeah, and all of this information is fed into a transformer model.
Another transformer.
Yeah, but unlike generative retrieval, they're only using the encoder part of the transformer.
Oh, okay, so just one part of it.
Yeah, and the encoder's job is to take all of that input information, all those embeddings, and create this single condensed representation of the user's interaction history.
Right, like summarizing all the past actions.
Yeah, and then that representation is compared to all the item representations in the system's library to find the most similar ones.
So it's finding the closest matches.
Exactly. And they measure similarity using something called cosine similarity.
Cosine similarity, yeah.
And that calculates the angle between the vectors.
Okay.
And the smaller the angle, the more similar those items are considered.
Interesting. So it's like a geometric approach to similarity.
Yeah, and then the items with the highest similarity scores, those are the ones that are recommended to the user.
Got it. So it's all about finding the best matches in that embedding space.
Yeah, and now that we've kind of explored how each of these approaches works, we can start to understand why they might perform differently,
Right.
especially when it comes to recommending those cold start items.
Yeah.
And one of the key factors seems to be the way they handle the item representation, right? Because dense retrieval, with that transductive setting, it has a richer source of information up front. It can leverage those text descriptions even for the brand new items.
Right, giving it an advantage in understanding those items.
Yeah, whereas generative retrieval, it's relying more heavily on those past patterns of user interaction to create those semantic IDs.
Right.
So when it encounters a new item, it doesn't have as much to go on.
Yeah, like trying to guess the next word in a sentence when you've never encountered that word before.
Exactly.
Yeah.
Yeah, and that's what the researchers observe. Generative retrieval tends to overfit to the items that it's seen during training.
Right.
So it becomes really good at predicting the next item within that set of items that it already knows.
Right.
But then when a new item comes along, it struggles to assign it a meaningful semantic ID
Yeah,
and to incorporate it into its predictions.
that makes sense.
And this overfitting, it's a significant reason why generative retrieval has trouble with those cold start items.
Right. It's limited by what it's already seen.
Yeah, and the researchers, they actually analyzed the generation probabilities of those cold start items in their experiments.
Okay.
And they found that the probability of the model generating a cold start item, it was consistently lower than for items seen during training.
Interesting.
So when the system uses beam search to explore those possible recommendations, it's less likely to even consider those cold start items.
Oh, I see.
They're almost invisible to the model.
So it's not even giving them a chance.
Yeah, and this highlights a fundamental challenge for generative retrieval. It needs to find ways to better generalize to unseen items.
Right. It needs to be more adaptable.
Yeah, if it can't overcome that overfitting problem, it's always going to struggle to keep up with the dynamic nature of those real-world recommendation systems where new items are constantly being introduced.
That's a good point. It needs to be able to handle the constantly changing landscape.
Yeah, and that doesn't mean that generative retrieval is doomed.
Right.
It just means that there's room for improvement.
Yeah, there's potential there.
And the researchers' development of that LIGER model, That's a step in the right direction.
It's promising.
Yeah, because by combining generative retrieval's efficiency with dense retrieval's robustness to those cold start items,
Right.
LIGER offers a potential solution.
I see. It's leveraging the strengths of both.
Yeah, and it also raises some interesting questions about the future of these retrieval methods.
Yeah, like where do we go from here?
Exactly. So will we see more hybrid approaches like LIGER?
Hmm.
Will generative retrieval evolve to overcome its limitations?
Good questions.
Yeah, and could it potentially become the dominant approach in the future?
It'll be interesting to see how it all unfolds.
Yeah, these are questions that researchers are actively exploring,
Uh-huh.
and the answers are going to shape how we discover and interact with content online.
That's for sure.
So now let's turn our attention to the specific experiments that the researchers conducted.
Okay.
They tested these models on 4 datasets.
4 data sets.
Yeah, 3 from Amazon, focusing on beauty, sports, and toys,
Okay.
and 1 from the gaming platform, Scheme. They used a standard method called 5-core filtering to clean the datasets.
5-core filtering.
Yeah, basically making sure that they were only looking at users and items with a sufficient number of
Makes
interactions.
sense.
And they also truncated user interaction histories to a maximum length of 20 items,
Okay.
focusing on the most recent interactions.
Got it.
And for evaluating the models, they used 2 common metrics, NDCG at 10 and recall at 10.
Okay. Metric.
Yeah, so NDCG, or normalized discounted cumulative gain.
NDCG.
Yeah, it measures the quality of the ranking of the top 10 recommended items.
Right.
So it takes into account both the relevance of the items and their position in the ranking.
So a highly relevant item ranked first is better than the same item ranked 10th.
Exactly, yeah, and then recall at 10,
Recall it 10.
that measures whether the correct item, the one the user actually interacted with, appears within the top 10 recommendations.
Okay.
So it's a measure of how well the model can identify relevant items regardless of their ranking.
Got it.
And the researchers, they compare their models against several baselines,
Okay.
including 5 state-of-the-art dense retrieval methods.
So they had a good benchmark.
Yeah, and they also compared against Tiger.
Tiger.
Yeah, that's the generative retrieval method using semantic IDs that we talked about earlier.
Right. Right.
And the results, they're quite revealing.
Okay, I'm curious.
Yeah, so let's break them down dataset by dataset.
Sounds good.
So starting with the Amazon Beauty dataset,
Okay, Amazon Beauty.
we see that LIGER, it actually outperformed all the other methods on both NDCG at 10 and recall at 10.
Wow, so it really stood out.
Yeah, and it also showed significant improvement in recommending those cold start items compared to Tiger.
Interesting. So that hybrid approach seems to be working.
Yeah, it suggests that that combination of generative and dense retrieval in LIGER,
Mm-hmm.
it effectively addresses that cold start challenge.
That's promising.
Yeah, and on the Amazon Sports dataset,
Okay.
we see a similar pattern.
Similar pattern.
Yeah, LIGER takes the lead again, with strong performance on both inset and cold start item recommendations.
Consistent performance.
Yeah, and the Amazon Toys dataset, it also shows LIGER outperforming the other methods.
So LIGER is doing really well across the board.
It is, yeah. But it's worth noting that on this dataset, Reformer, that's a dense retrieval method,
Okay.
it showed competitive performance, particularly on those cold stored items.
Interesting.
So this indicates that while LIGER is showing these promising results, there's still room for improvement.
Yeah.
Other dense retrieval approaches are making strides in addressing that cold start problem.
Right. So there's still competition.
Yeah, and finally on the Steam dataset,
Okay.
which is significantly larger than those Amazon datasets.
yeah, much larger scale.
LIGER again showed strong performance.
Okay.
However, the performance differences between the various methods, they were smaller on this dataset.
Smaller differences.
Yeah, and that might be due to the larger scale of the data. It could be providing more information for all the models to learn from, lessening the impact of those cold start issues.
That makes sense. More data to work with.
Yeah, so overall, these experimental results, they highlight the potential of those hybrid approaches like LIGER.
Mm-hmm.
They seem to be striking a balance between the efficiency of generative retrieval and the robustness of dense retrieval.
Right. Getting the best of both worlds.
Yeah, especially when it comes to recommending those cold start items.
It's a promising direction.
It is, but they also raise these intriguing questions about the future direction of research in this field.
Yeah, like where do we go from here?
Exactly. So will generative retrieval evolve to overcome its limitations, or will those hybrid approaches become the new standard?
Those are the big questions.
They are, yeah, and that remains to be seen. But these are exciting developments,
Definitely.
and they're pushing the boundaries of how we personalize those content recommendations online.
It's fascinating to see how this field is evolving.
It is, yeah. And let's pause here for now. We'll continue our exploration of generative and dense retrieval in our next segment.
Sounds good.
We'll dive a little deeper into the nuances of these approaches, and we'll examine those potential future directions.
Looking forward to it. Welcome back to our deep dive into recommendation systems.
Okay.
So let's delve a little deeper into the nuances of dense and generative retrieval, considering, their strengths and limitations.
Right. And we previously talked about those semantic IDs in generative retrieval. They offer efficiency and they capture those semantic relationships.
Yeah.
But they also introduce that layer of abstraction. And that can impact performance.
Right, because by converting those item descriptions into codes, you might lose some of the granular detail that could be crucial for accurate recommendations.
It's almost like, trying to summarize this complex novel with a single sentence. You capture the main idea, but all those nuances are gone.
Right.
And that loss of detail, it could be contributing to generative retrieval struggles with those cold start items.
Yeah, because when a new item comes in, the system has to rely on a limited set of codes to represent it.
Right.
Which may not be enough to capture its unique characteristics.
Yeah, whereas dense retrieval, using those text embeddings directly, it retains more of that granular information.
Right, but that comes at a cost.
Yeah, what's that?
Dense retrieval requires significantly more computational resources.
Oh, I see.
Especially as that item count grows.
Makes sense.
Generative retrieval, though, with its compact semantic IDs, it's much more efficient.
Right, so it's a trade-off.
It is.
Another key difference is how they handle sequential information.
Okay, sequential information.
Yeah, so dense retrieval, it typically uses the encoder part of the transformer to create that condensed representation of the user's past interactions.
Right.
Generative retrieval, though, it uses both the encoder and decoder parts of the transformer.
Both parts.
Yeah, in the decoder, it's specifically designed to generate sequences,
Right.
making it suitable for predicting the next item in a user's interaction history.
So it's looking at the flow of interaction.
Exactly, yeah, and that sequential generation capability, it's one of generative retrieval's strengths. It allows the model to capture those more complex patterns of user behavior over time.
Makes sense.
Whereas dense retrieval, with its focus on finding similarities in that embedding space, it might miss some of those temporal nuances.
Interesting.
And let's touch on the LIGER model again.
Okay, LIGER.
So it combines elements of both dense and generative retrieval.
Right, the hybrid approach.
Yeah. And the researchers tested LIGER on various data sets, comparing its performance against other state-of-the-art recommendation methods.
Okay.
And they found that LIGER consistently performed well.
Really?
Yeah, particularly in scenarios with those cold start items.
Interesting. So it seems to be handling that well.
It does, and this suggests that these hybrid approaches like LIGER, they hold considerable promise for improving recommendation accuracy.
It's a promising direction.
It is, yeah, and this research, it highlights that ongoing evolution of retrieval methods in those recommendation systems.
It's a constantly evolving field.
It is, and it also underscores the need for further exploration to refine these approaches and to address their respective limitations.
Yeah, there's always room for improvement.
Always. As we wrap up our deep dive into dense and generative retrieval in these recommendation systems, what are your final thoughts on the potential of these approaches?
Well, both methods have, those distinct advantages and disadvantages.
Right.
Dense retrieval, it demonstrates robustness.
Yeah.
Especially with those cold start items. But generative retrieval, while it faces those challenges with the newer items, it offers that impressive efficiency.
Right. And that hybrid approach, LIGER.
Yeah.
LIGER seems to offer a compelling path forward.
It does.
Leveraging the strengths of both methods.
Absolutely.
And this research we discussed, it really highlights that ongoing innovation in recommendation systems. It's a field that constantly seeks to refine how we discover and engage with content online.
It really is, and it makes you think about how these algorithms, they shape our online experiences. Suggesting, new products, movies, games we might enjoy.
Yeah, it's pretty amazing.
It is, and this deep dive, it's provided a glimpse into the complexities of those systems.
Right, we've delved into the mechanics of dense and generative retrieval. We've examined their strengths and weaknesses.
Yeah.
And we've explored the potential of those hybrid models like LIGER.
It's been a fascinating exploration.
It has, and the research in this area is so dynamic.
Absolutely.
Future developments, they'll undoubtedly lead to even more sophisticated and personalized recommendations.
I have no doubt, and it'll be interesting to see what the future holds for this field.
It will. And that brings our deep dive to a close.
Thanks for having me.
Thanks for joining us.